Thank you very much. Good. Okay. Nancy began birding in 2012, and I would say she's a very avid birder. In 2015, she retired, and birding has become her consuming passion. She birds every day and has submitted eBird reports for 3,100 consecutive days, which I think shows you her dedication and enthusiasm for the hobby. She also has a passion for pelagic birding, and you can find her on the ocean as often as possible. And she lives in Ramona with her husband, Russ, and I believe they live on 5 acres up there. So probably do a lot of birding right on your property.
Yep.
Yeah. So as I said, she's put together tonight's program where she will present a large variety of bird bill shapes and sizes and ways they are used to benefit specific species. We have the pliers, the scissors, the chopsticks, etc. And I know that Nancy spent some time at Home Depot looking at tools and collecting tools for this presentation. So I will hand it over to you, Nancy. And if you all have any questions, you can hang on to them until the end, and Nancy will take questions at the end.
All right, well, thank you very much. I will share my screen. And do that. Wait, did it do it? There we go.
Yes.
And I want to change this to just me. Okay. Everybody can see the screen okay?
Yeah.
Yes. Right. So as Deborah was saying, tonight I wanted to talk about adaptations to the bills of the birds and how they help them to survive. So birds overall have a lot of adaptations that we think about. Many birds have an incredible set of plumage that they can use for showing off and attracting mates. Some of them just look beautiful, and you think to yourself, why on earth would a bird be red and green? But it works. It's a beautiful bird. Other species, their feathers help them to blend in and make them very difficult to find. And we here would have the western screech owl, but it's the same idea. It will just disappear into the woodwork. Birds have a very light bone structure, and they have feathers, and those are all adaptations for flight. And feathers also provide weatherproofing for those species who live on the water. These are Scripps' merlets, which we see offshore here. And within a day or two of hatching, the babies jump into the water, and then they spend their entire lives on the ocean. They never go back to shore except to nest. And, you know, those feathers have to keep them protected. Other physical characteristics that birds have are also survival strategies: long necks, long legs, and in this case, this lets herons access prey in the marshes so it can wade in the water. Long toes for this bird helps it walk on floating vegetation out in the marshes. But for ducks and gulls of all sorts, those webbed feet are what makes life easier for them, helps them to swim. Penguins don't have long necks or long legs or fancy feathers, but they do have a thick layer of fat that insulates them, allowing them to survive in the harsh conditions where they live. But tonight it's all about the bills. There are many remarkable adaptations on bird bills, and they come with a huge variety of sizes, shapes, colors, from the generalized types to the very highly specialized bills. These are the tools the birds use to survive. We use our hands for working, and over the centuries, a large number of tools have been invented for each type of job that we as humans need to have done. When you walk into Home Depot and you look at the tool wall, it can be bewildering. If you've ever had to go buy a tool for somebody as a gift or because your spouse has sent you and said, I need blah, 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 it's overwhelming. There's so many choices. Do I get the big one or the little one? A long handle, a short handle? What is the best tool for that particular job? The kitchen's no better. When you go to Target, you see the wall of tools that you use in a kitchen. So which tool is exactly the right one for each job? So I think of the basic bill on a bird is very much like a pair of needle-nose pliers. The basic function of all bills is to gather food. After all, every bird gets its nourishment through its mouth. Needle nose pliers are tools for picking things up, and tonight these represent the most basic function for any bill. Pick up the food so it can be swallowed. In this case, I'm showing a semi-palmated plover and a cerulean warbler. Both have a very basic bill. The basic needle-nose bill is ideal for picking up small pieces of food, bugs, caterpillars, small bites of this or that. Many warblers and shorebirds sport this type of basic bill. Most plovers just run a few steps. I guess I needed to back up. Most plovers just run a few steps and then stop to pick up the food. Some sandpipers probe for food, while others are using the hunt and peck method. Lesser yellowlegs is an example of a bird that uses the hunt and peck. It doesn't probe into the mud, it picks things off the surface of the water. Having a generalized bill probably means you're going to eat generalized food as well. That means probably swallowing the food whole. Your bill isn't, this type of bill isn't made for tearing things up or shredding the food. You swallow it whole. Many species of flycatchers have a basic bill. As you can see in this case, the Hammond's flycatcher and a forktail flycatcher. Now, here's two fly-catching birds, each from different continents. The jacamar and the bee-eater look very similar. They both have these very extremely long bills. They both live in burrows of all things. They dig burrows with those bills. But they, why do they have this elongated bill? Why is their basic bill has been stretched out and made long? And I don't know for sure why, but I have a theory. I think both of these two species eat insects that sting, and therefore they have long bills to keep that insect away from their soft flesh of their face, so they cannot be stung by their prey. Another elongated type of basic bill, they're more like tweezers really at this point. Here's the pinion jay and the Clark's nutcracker. Both of these two species dig into cones and pull out pine nuts, but they handle the nut differently. The pinion jay will then hold the nut in its feet and bang on it to open it so it doesn't eat the shell. It only wants the nut inside that shell. The Clark's nutcracker will crush it with its bill and get the meat of the nut. So as the bill becomes more elongated, a little more specialized, it almost becomes like a pair of chopsticks. Chopsticks can pick things up, but they can't put any real pressure on them. And dowagers is a good example of that. They have straight probing bills. They find the food by feel, inserting the bill into the mud until they touch something. Then the food item is drawn out of the mud and consumed. Dowager bills are quite rubbery, and they can be flexed open enough to grab the piece of food. In the photo on the right, you can see that bill it's actually curving that bill. It can change the shape of the bill. We think of them as being hard and rigid, but not all bills are. Godwits also have a probing bill. Theirs have a slight upward curve. Imagine you're poking your finger down into wet sand, and the deeper you push, the harder it gets as the sand gets compacted by the pressure of your finger. By making that slight curve, it slides past that pressure point. So the design of this bill allows the bird to probe more deeply than it would be able to otherwise. And once again, it can flex this bill. The photo on the right, excuse me, on the left, shows the godwit actually flexing the bill so it can pick up something with the very tip. The longer the bill, the more the curve has to be exaggerated. Otherwise, it would quickly reach a point where it could not push down deeply enough. Obviously, a long-billed curlew probes much more deeply than a godwit, and in this case, the curve is towards the bird, but even so, that curve allows the bill to keep sliding through this wet sand without building up pressure of resistance. So here's a bill with a very similar shape and actually size of the long-billed curlew. This is a red-billed scythe bill, and it lives in tropical jungles. It feeds by investigating cracks and crevices in tree bark and probing into bromeliads and epiphytes for insects and invertebrates. So it's using its bill to probe into softer plants as opposed to mud. Now, I was only able to think of two species where their bills have developed into probes. By that, I mean bills that they actually stick on the end like you would with a toothpick picking up an appetizer. They stick the food on the end of their bill and then pull it out that way. This is a critically endangered species from Hawaii. I don't know that I can say its name. Akiapolo'au, maybe. It's got that very long, slender probe for an upper bill and then a short lower bill. And it sticks that upper bill down into little tiny holes, stabs little grubs, and then pulls them out. I recently saw a photo of one of these, and it looked to me like it can actually flex that bill to get that grub up to where it can grab it with the lower bill as well. So that end tip seems to be fairly flexible. The other probe type of bill that I thought of was the snail kite. It uses that long pointed piece to sweep down inside the apple snail and get the meat out of it. There's probably other birds with probes, but if I haven't photographed it, then typically I haven't learned too much about it. So I'm going to switch to a different bill type here. These are side cutters. We looked at needle nose pliers as an illustration of a basic bill, and then we looked at variations on that theme with the bill getting longer and longer and becoming more like chopsticks. In my mind, this is the second most common basic bill. This tool is used to apply pressure, but it uses pressure along the edge, the long edge of the bill, instead of using the tip of the bill. So sparrows are a perfect example of this. Sparrows eat small seeds, but they also dine on bugs. Most seed and fruit-eating species will have essentially triangular bill, and the edge of that bill has a cutting edge. It's a cutting surface. So most of the seed-eating birds do not eat the shell or the hull on the seed. They actually peel each and every grain of seed that they eat. And here you can see the house finch is very carefully using the side of its bill to shuck off that outer hull, and then it will swallow what was inside of it. So the larger the seed, the larger the bill needs to be. House finch couldn't open some of the same sorts of nuts or fruit that a cardinal could. The cardinal needs that bigger bill for a bigger seed. And even the rose-breasted grosbeak, the uses that bill to open larger seeds yet. So the bigger the bill, the bigger the food that that bird can consume. Now, one of the strangest bills we see among birds, at least to me, is the red crossbill. They seem to have like a Swiss Army knife for a bill. It's basically a multi-tool combining tweezers and side cutters. The long twisted points are used to scissor out seeds from pine cones, the way we saw the jay or the nutcracker pulling the pine seeds. These can reach right in there, and they use that crossover bill to break that seed loose and pull it forward. And then at the back part of its bill, it's got the side cutter effect that all of the other finches do. So it works both ways for these guys. And I want you to notice that some of them cross to the right and some of them cross to the left. And there doesn't seem to be any rhyme or reason to that. There's lefties and righties. So variation on a theme of the type of bill that applies pressure would be these adjustable pliers. Sometimes a task needs more leverage, more power, and then you use adjustable pliers. And that's just like what the parakeets use and the parrots. They have a huge crushing bill that's still a triangular bill, so you can tell that they're pretty much seed eaters or fruit eaters. A lot of the fruits, tropical fruits especially, have very thick skins. They're hard to open, and they need a lot of force for these birds to crack them open. So this is the largest, the hyacinth macaw is the largest flying parrot species. The hyacinth also has the largest bills. Now they mostly feed on the very hard nuts that come out of particular types of palm trees down in South America. They need those big bills to crack open those seeds. They also dig through the droppings of the cattle. There's lots of cattle farming down there. The cattle will also eat those same seeds when they've dropped to the ground, and passing through the digestive tract of these cattle softens the hull of those shells, making them a little easier for them to open. So the hyacinth uses that pointed tip to dig through the droppings of the cattle, looking for palm nuts that they can eat. But the shape of that bill reminds me of a carpet knife. So carpet knives are sharp on the tip, but not along the edges, and they're used to rip and tear. Now that's a behavior I would associate with eagles or hawks, birds of prey. So hawks, eagles, owls, and vultures all have strongly hooked bills. Big surprise, that bill size is directly related to the size of the prey that each of these species eat. You know, a small owl like a burrowing owl is going to eat mostly insects or maybe small critters of some sort, and they often swallow their food whole. Whereas the hawks hunt larger prey and need to tear it to pieces before they can swallow the chunks. This tawny eagle from Africa takes much larger prey. It's a large bird. They often eat young antelope, and that heavy bill can be used to sever the spinal cord of the victims. So it actually cuts right through into the cord and kills the animal. Now, vulture bills are hooked, but there's a hierarchy among vultures. The largest billed birds, the largest vultures, need to eat first. They're the ones that can open the skin of the dead animals. Most of the African animals have fairly thick hides. It takes a large bill to tear it open. A lot of times you'll find smaller vultures like the white-backed vultures just sitting around waiting for the big guys to arrive and open up the dinner plate. There are numerous species out there with smaller hooks on the ends of the bill. And usually what these hooks are for is to help them to control slippery prey items. In this case, it's a neotropic cormorant with some crazy fish that really does not want to get swallowed. A scissortail flycatcher here is an example of a predatory bird that has a hooked bill. Unlike the other flycatchers we looked at earlier that just had basic straight bills, this one's a little bigger bill and it's hooked on the end to help it hang on to the slippery and shiny, often, the insects a lot of times have that shiny hard carapace on them, and that helps them to hang on to them. In this particular case, this was a very uncooperative insect, and it took a lot of banging and tossing around before it was subdued enough for this bird to eat it. These little hook bill type birds include flycatchers, vireos, and the shrikes. And we've all seen the shrike around in San Diego. So I've spent a lot of time talking about the two basic types of bills, the side cutter and the pliers, just the pliers. Well, here's a whole bunch of other examples of bill types or bill functions that we'll address just very briefly. There's so many variations, there's so many strategies for acquiring food. The can openers, straws, strainers, mouse traps, all of these have analogs in the avian world. Take the spear. An anhinga is an example of a fishing bird that uses their bills as spears. Possibly most of the time the fish is grabbed rather than impaled, but often you will see the bird has truly speared and poked that bill right through the fish. Kingfishers typically dive headfirst into the water after their prey. Herons come with a whole variety of bill size, differing in length and stoutness, and that all depends on what kind of food they're going after. But most of the herons stalk or wait until the prey is in a good position, then launch their head forward with a stabbing motion. And that's how they grab a fish. Now, boobies dive headfirst into the water, and as large, heavy birds, they hit the water with incredible force. You might notice that boobies have no external nostrils. There's no nose hole on this anywhere. They breathe through the little corners of their mouths. And that entire family just doesn't have an external nose at all. Now, a strainer, that's pretty much like filter feeding. Flamingos are true filter feeders. Their bills have structures that resembles the baleen of the large whales. They swish their heads to and fro and use their large tongue to push the water out past those filters. Some penguins feed the same way, hunting for krill. And then here's a duck we're all familiar with, the northern shoveler. If you look very closely, you'll see at the edge of the bill, a comb-like structure is there, which it uses to strain the water for small organisms. When you see the shovelers feeding in a group, they swim in a tight circle, they make a little whirlpool effect and bring debris and stuff up off the bottom of the pond that they're working in, and then they strain the water that's coming up looking for edibles. So a mouse trap, that one seemed funny. So spoonbills and avocets sweep the water back and forth, and you might think they're behaving kind of like a flamingo, where they're straining for food, but no, in fact, they're both hunting by braille. They are feeling for frogs or fish or crustaceans, whatever. They sweep back and forth, and when they feel something, their mouth snaps shut quickly and grab the food. Jabiru and woodstarks hunt the same way. And oftentimes these guys are fishing in very murky water. They can't possibly see the fish or the frogs that they're going to end up eating. So they're truly fishing by touch only. And they just have to have a quick reflex. When they feel something, they have to snap their bill shut. So another example of a bird that acts like a mousetrap is the skimmer. Skimmer bills are really unusual. The lower bill is longer than the upper, and they're compressed sideways. So they're, especially that lower bill is like paper thin. So as it flies along the surface of the water, it drags that lower bill through the water. And once again, it's feeling for food. Most of skimmers feed most of the time at night. You see them sometimes during the day, but most of their feeding occurs during the dark. So they're truly fishing by feel. And when they feel something, they snap their head down and that lower bill comes up and it tosses the food item up into their mouths. So a straw is kind of the analog for nectar feeders. And they aren't really sucking the nectar out of the flowers, but their bills kind of look like straws. So that's the symbol I used for this. In the old world, there are a whole group of birds called sunbirds, and these are the nectar feeders. They insert their bills into the flowers and basically lick the nectar out of the flower with a tongue that they stick down into it. Hummingbirds in the New World fill that niche. The bill shape and size is of the various species are adapted to the flower shapes in that area. And oftentimes hummingbirds are adapted to specific flower types. And like birds like this Planalto hermit won't ever come to a feeder. It will only go to the flowers that it's adapted to feed on. Around here, we have the Anna's hummingbird and the Rufus hummingbird, which have, relatively short bills, nothing special, very, what I would call a generalized hummingbird bill. Now, there are some nectar drinkers that don't have a good bill at all for getting to the nectar, and they have to have a different method for getting to it. And for this, I've used a can opener. So there's a group of birds called flower piercers, and look at the shape of that bill. It's got that little hook on the end, and the bottom bill comes up and it's like the little flange that grabs the edge of the can. So flower piercers come along and they pop holes in the ends of these bigger flowers that they don't have a bill to reach up inside. So they pop in there, make a little hole, and they can drink out of that little hole. And you can see in this group of flowers, you see my cursor, there's a hole up there, there's a hole here. So this flower piercer has visited all of these flowers. Well, in the same area, there's a little hummingbird called the volcano hummingbird, who's very tiny, very short bill, and it just follows along behind the flower piercers and drinks out of those same holes. So, whatever works. It's found a way to get hold of the nectar, and it kind of cheats the flowers because nobody's pollinating using this method, but the birds themselves are getting their nectar. So the next tool I noticed was the pry bar, or we call it a cat claw. Anyways, it's this kind of curved metal bar used for prying things up, like nails that shouldn't be where they are. Check out the shape of the white-breasted nuthatch bill. It's exactly the same thing. This bird is adapted for flicking off little bits of bark and stuff off the tree as it searches for insects. Ruddy turnstone is another bird, that same shape, that little wedge shaped underneath. And in fact, what it does is it flips off little shellfish or mollusks that are on the rocks, turning over stones, so they say, to get at food items. Down in South America, there's a variety of other things. The xenops and the wedge-billed woodcreeper are other birds that both use their bills as pry bars to open up cracks and get into the bark in a more efficient way to find the food items that they want. Now this is a chisel. Chisels come in lots of different sizes and shapes. If you've ever done any woodworking, you'll know there's usually when you buy chisels, they come in a set and there'll be 6 different sizes in the one little package. Well, that's the woodpeckers. So this particular woodpecker has a fairly small, fine bill. Now, as far as I know, all woodpeckers chisel out holes for themselves to nest in. And of course, the size of the bill is going to have something to do with how, is there softwood? Is there hardwood? What kind of wood is it that they're getting into? So this one has a relatively small, fine bill. And our local acorn woodpecker has a much sturdier, heavy bill. And if you think about it, if they spend much time banging on oaks, which are a hardwood tree, you know, that they probably need a much heavier bill. Of course, acorn woodpeckers spend a lot of time making additional holes. It's not just a nest hole that they're interested in. They're interested in storing acorns. And so they make hundreds and thousands of holes in order to store up acorns. And some of the larger woodpeckers, this one is the crimson crested. It's the same deal with the pileated woodpecker here in North America, very large crow-sized woodpeckers, and they just tear trees apart. I mean, they make these huge areas of damage on the trees as they're looking for insects. And, you know, generally what they're tearing apart are sick trees that are infested with some sort of wood-eating grub, and that's what they're looking for. Now, so sapsuckers are another kind of woodpecker that chisel, and I've put the two side by side here so you can see the different kinds of holes that they make. So on the left is the red-breasted
Not allowed to
sapsucker.
help yourself.
Somebody's, oh, there you go. The red-breasted sapsucker makes a set of holes that it often ends up combining together, and it makes these kind of long, streaky sap wells. On the left is the yellow-bellied sapsucker, who makes little rows of holes, you know, perfectly even, pretty even rows of holes that go around in a circle around the trunk. And they often come back to the same tree year after year. This particular one, the upper layer here are this year's holes, and then there was last year's holes, and then other holes that are probably 2 or 3 years old, not from this bird. This is a hatchier bird. But obviously this tree has been used many times by other yellow-bellied sapsuckers. So sapsuckers, you know, they make the holes to get the sap to come out. A lot of insects get stuck. They can kind of lick up some sap, which they eat, but they also get the insects that are stuck in the sap. And a lot of times these are great to find because you'll find other small birds coming to feed either on the sap or on the insects that are stuck there as well. A lot of times warblers will come feed on sap wells. So it's a good thing if you find good sap wells, keep checking them. Another tool type is the serrated edge. This case it's pinking shears. There are birds that have serrated edges on their bills. Geese, all true geese have serrated edges on their bill. They are grazers, they eat grass, and that's how they cut the grass, is with that, the shape. And you can see this guy here very carefully cutting the grass with his scissors. Other serrated bills are things that eat fish that might be slippery, in this case, a red-breasted merganser. Now, tongs are a tool I use quite a bit in the kitchen. I don't know about you. And the birds that seem to have bills most like tongs are hornbills. And so these are things for, tongs are used for grabbing things, but they're not for putting pressure on it. These bills are not used for breaking open seeds, for example. These are for grabbing things and then tossing them in. I'm not sure why they all have to be quite so big, except perhaps they reach inside holes. I know for a lot of hornbills, they seal their mate inside of a hollow and they feed their mate through while she's sitting on the eggs and such, and they have to be able to reach through that hole in order to feed the mate. And so maybe that's one of the reasons the bills are long. Some hornbills have decorations on top of their bills. In some cases, they think that those are for amplification of sound. In other cases, they think it's perhaps just a sexual characteristic. It's one of those things that may not be the same answer for every species of hornbill. This one is, well, I thought this was interesting for one, because how worn the bill is. In the center of the bill, you can see it's worn quite a way. And also that the casque on top is actually peeling. So it's got some sort of self-regulating mechanism that keeps the casque exactly the right size. And it appears to be open or hollow at the end. So this one may indeed be for sound amplification. The Araceli, this Araceli has a serrated bill. This adult on the left, a heavily serrated bill. But on the right-hand picture, what you're seeing is a fledgling being fed by an adult, and you can see the edge of that bill is smooth. It is not born with a serrated edge. My guess, I tried researching this, I found no information. My guess is that as it picks up nuts or fruit and it tries to do it, it chips away at its bill and it creates these tooth-like projections as part of its feeding process. Here's an older individual. It looks like it's broken off a lot of those tooth-shaped things. And once again, I just don't know. I don't know enough about these. Do their bill keep growing? Is this bird just going to age out when its bill is too worn out to do things? I just don't know. I don't know enough about these birds. Toucans are another species with a very large, colorful bill. Some people say that this is an amplification of the noise, and if you've ever heard a toucan, they're extremely loud. You can hear them for miles. And some people think it's actually a way to distribute or to burn off heat, to allow heat to escape from its body. And others thinks it's just pretty to attract its girlfriend. This is just what they are. Because oftentimes birds are interested in attracting. In this case, my little statue of an owl feels very pretty looking in the mirror at himself. So bird bills are used for courtship. The American white pelican, which we see in winter, and we don't always get to see this happen, it gets these flanges or horns on their bills during the breeding season. Once the eggs are laid, those horn things fall off. Presumably, these are a visual signal that indicates that this bird is ready to breed. Now, the ruddy duck, not only does it change its plumage for the nesting season, it actually changes its bill color. In the winter, it's got this dark, almost black bill, and in the spring, it's got this baby blue bill. The female doesn't change at all. She stays the same all year round. Pied-billed grebes, once again, it's the same deal. In the winter, the pied-billed grebes have a plain bill, no marking. And during the spring, it's got this nice stripe on the bill. And I was going to point out on the left-hand side, the chick that's there has a red bill. So it changes from red to plain and from plain to striped. And then these adults, the male and female are just alike in this species. These adults will go back to having a plain bill as the season moves along. We have tufted puffins. I've only seen them twice in San Diego, but they change dramatically. So the bird on the left is a winter bird. The bird on the right is a spring bird. this species grows a sheath on its bill that will actually fall off later. So it grows an extra piece on that bill. You can see the shape of the bill is different between spring and winter. They totally change. It astounds me that that much can happen. But this grows a horny part over the top of the bill. It's just there for the breeding season and then falls off, kind of like an antler on a deer would fall off. Now, most of the bills we've been talking about are adaptations relating to gathering bills, although some are obviously adaptations just for courtship. Oh, never mind. That's not what I meant to say. We have always been told that birds have very little sense of smell, yet there's an entire family which is noteworthy for their sense of smell. Out on the ocean, we have a group of birds called tube noses. Albatrosses are one of the tube nose family. You can actually see on the left-hand photo the little tiny tubes sticking out of the bill on this albatross. These birds find their food by scent, and they can smell things for many, many miles out on the ocean. Tube noses include albatrosses, storm petrels, fulmars, shearwaters, and petrels. So this is the southern giant petrel, and you can see it looks like it's got one very large tube on the top of its bill, reaches all the way down almost to the tip. I don't know if the size of the tube is related to how sensitive their sense of smell is, or if there's some other reason there's so much variation. So this is a fulmar. So most of the tube noses have bills that are made up of plates. It looks like it's like 6 or 7 separate pieces that are kind of glued together, and that's exactly what they are. It's less obvious in the albatross. It's most obvious in the fulmar. But you can see all the little pieces, and the little bit up on top is its tube nose. It's scent organ. This is a Wilson storm petrel, and it's got a little tiny tube up on top of his nose as well. They think that the tube nose, that this ability to smell actually helps them find their burrows as well as find their mates. You know, how do you pick out which one of these birds are yours, or, you know, which is your mate, which is your chick? And they think that by scent is the way some of these birds communicate. So I decided to add in a few nests that birds have built using their bills. This is the bladderback woodpecker out in the desert. All woodpeckers make some sort of a hole to nest in. Some of them make holes to escape the heat, and so they're in even, or the cold, you know, so woodpeckers may go inside of nests for more things than just nesting. Grebes make a nest in the water by dragging water plants over and piling them up on top. This nest has got a bit of a challenge to it, because if the water level drops, the bird will not be able to get up in the nest. These grebes don't walk well on land. Their legs are placed very far back on their body, and they cannot possibly climb up onto something if it's very high out of the water. And it's the same thing, if the water level rises, the nest will be drowned. So, you know, it's kind of a perilous place to nest. Now, many swallows make their nests out of mud. This is a barn swallow, so it's got mud and it's got vegetable material that it's mixed together to make kind of a cement that it builds its nest out of. This is a species of swift that's in back of this is behind the falls at Iguazu Falls in South America, if any of you have been to that. This nest is also made entirely of mud and some vegetable matter. And it's wet all the time because it's in back of a waterfall. So they must have some sort of a binding property in their saliva that helps it hold together. And in fact, as I'm sure you've all heard of the species of swift, that the cave switlet swiftlet builds its nest entirely of saliva, and that's the nest that's highly prized for making bird nest soup. So the nest itself is the only ingredient in it is swift spit, and they boil that up and turn it into soup, a very expensive soup. Here's another type of mud nest. This is hornero nest. A hornero is a type of means oven, and this is in the family group of oven bird, and it builds this nest that bakes out in the hot sun, but it's insulated, and because of what it's made of, it helps keep the bird cooler inside in the very hot weather. This is a more traditional type of nest that's been very carefully woven of vegetable matter, and it's covered on the outside with lichens to help it blend into the tree branch. And this is a weaver. Weavers make very elaborate nests. Many species of weavers in Africa. This pair has built the two vertical structures, and they're getting ready to combine them into whatever else they will be doing with this nest. And it's just amazing to me how intricate. Look at this one made by a grosbeak weaver. The hundreds and hundreds of pieces of fiber that it has used to build this nest out in the reeds. So I'm not an expert in any of this, but what I like to do is when I go birding, I like to look at a bird and I think, why is it like that? What is the purpose of this thing? Or why does it have a yellow spot on its breast? And maybe that's a bit of childlike wonder, but it makes me go back again and again to look at the birds some more. There's so many fascinating adaptation the birds have, and looking at the bills is just one little tiny piece. And I obviously don't have answers to all the questions that I have in my own mind about a lot of these the bill adaptations, but it keeps me wondering, keeps me learning, keeps me going back to look for more. And that's it.
Thank you.
You're welcome. If
Can you
anyone
hear me
has any
okay?
questions.
Yes, do we have any questions? I think that was a lot of information. It was very fascinating. It gives you a lot to think about, that's for sure.
Well, that's good.
Now, how many of those photos were yours, Nancy?
Every one of those are mine.
Oh my gosh. So you have
Yes.
been, you're a world traveler.
Not as much as I'd like to be. But
That
yes,
is
I've been lucky enough to take a few trips, and and then a lot of the birds, we have such a great place here in San Diego to look at birds.
definitely. Yes, you have a lot of species that I haven't even seen yet, so I'm excited.
I'd like to make a comment. Nancy,
Yes.
this is Jody. I'm Mike Whitmer's other half.
Oh,
And-
hi.
Hi. He comes home frequently from birding forays, talking about how you've spotted something or you've seen something, or and he sings your praises at a birder. But I have to say, this presentation was awesome.
Oh, well, thank
have
you.
enjoyed it so much. Thank you for such wonderful information.
Well, you're more than welcome. It's a lot of fun, and birds are everywhere, and you can go anywhere and sit and enjoy looking at birds. And even if it's something common, there's things that we can gather from that information.
See you on the trail, Nancy.
Yep.
No, it really makes you think too. I had never thought about birds and the sense of smell, their sense of smell.
I know. Well, people
And
say,
not all
oh,
of them.
they
Yeah.
can't smell, but some of them
Right.
specialize in that.
Yes.
So
Yeah, that's amazing. Well, thank you very much. And this was a great way to get back into our speaker series. So I'm excited.
You're
And
great.
anytime you want to join us, feel free.
Well, thank you. And thank you for inviting me.
Uh-huh. Thank you. And everybody, hope to see you October 15th is our next speaking presentation. Thanks a lot, Nancy.
Sure. I think, did you turn off the recording?
I will do that now.
All right. Good night,
Thank you.
everybody.
Bye-bye.
Good night.
Good night.